Yeah. So actually today we are pretty much honored to have you guys here. So you guys are the legendary entrepreneurs, and it's really, really amazing and inspiring story. So you guys were born in France, never studied in the States, and you had your degree in Paris, and you guys moved to the Silicon Valley in your mid-20s and spent the time more than 10 years in Oracle.
So more than, actually, I came in the US in 96 and Thierry in 99. So 16 years at Oracle, 13 years for him.
A lot of Korean entrepreneurs and engineers, they are also interested in moving to the Silicon Valley. So what made you move to the States back then, 1996?
So at the time I was working for Boule, which was a French IT company, a little bit like IBM, but for France. And they were their machine, were running the Oracle database system. And I was doing research at the time in databases. So I was hired by Boule, to take care of all their databases. And I was sent to Oracle to port the Oracle database on top of the Boule platform. And I love it so much in San Francisco because I wanted to be a software, right? I was doing research in databases. I was not really interested by hardware. So I decided to join Oracle because at the time, in France, it was not a great environment to do software and software was not really recognized like it is in the US. So that's why.
Yeah. So what about your Thierry? Yeah.
So at the time, I was working for IBM. I was part of the European Center of Applied Mathematics, and I wrote a very long proposal, actually, as part of that work to integrate data mining algorithm and text mining algorithm in database system. And I shipped that to the US, to the research center that we had in the US at Almaden, and we had no reply. No answer, no reply. Nobody cared about what we were doing, and I was so excited about it and a little bit frustrated about it. So I decided that if I wanted to do things, I would have to be much, much closer to the development of the engineering of this database system. Otherwise, it will never work.
Yeah, actually, 1996 was right before dot-com boom. Yeah.
And the funny thing is that So I was working at Oracle, and then my boss at the time in 99 told me, we have a resume from a French guy, and I called, this French guy, and I cannot understand anything about what he says because of his French accent. Yeah, because of his accent was so thick. So Benoit, can you interview that person who was Thierry? So I called Thierry. Thierry was in France. And I interviewed Thierry, and we discovered that we did the same PhD in France, and we went, both to live in Germany. So we almost met in France, and we didn't met. So we met the first time in 99 when he came to interview at Oracle.
So you guys are best friends at that time on? Yeah.
We were.
Since then.
Yeah, interesting. Could you please tell me about the Oracle? Because you guys spent more than a decade in Oracle. So, and I watched in the other interview of Benoit said that you were a little bit disappointed at the Oracle. Then Oracle was losing the big data opportunity and the cloud opportunity. So what exactly happened? Why did you leave Oracle?
Yeah, so, we loved, both of us, we love our time at Oracle. We were in the core database group, building, for the data warehouse. But yes, after, 16 years, we realized that Oracle was missing two important revolutions. One revolution was big data, right? It was Hadoop at the time, and the ability to do analytics on semi-structured data, on machine-generated data at petabyte scale, right? This is what Hadoop was doing. But we thought that Hadoop was such a bad solution because it was slow. You would ask a question and you would only get the answer the next day. I exaggerate a little bit, but that was, and it was complicated to manage and very difficult. But at the same time, we also thought that there is no reason to have a system just for semi-structured data and a system for structured data like data warehousing. So we thought, it should be only one thing that can do both. very well. That was one idea, I mean, for Snowflake. And the other idea was the cloud. Analytical systems are very, spiky, right? You want to ask questions and you might use them for a few hours or few minutes, but then, you don't use them, or, their load is very up and down. And when you want to do a lot of analytics on them, you are going to consume a lot of compute power. So the cloud we thought was a great place because, in the cloud, you can provision resources and, for the first time in the cloud, software can drive hardware. That was magical to us because if you think about the old days of Oracle system, right? Someone would decide, okay, this software needs to be installed on that machine. And that machine, I'm going to configure it with that much memory, that many, CPUs or this set of machines. And the software will be confined in this environment and had to survive potentially in a bad house. It's like when you were born, someone put you in a house and might be a great thing or not a great thing. So we thought that, if software could decide what is good, and depending on the demand, of course, it's not a static decision, and can, ask for more hardware and expand to more hardware or contract, right, when it's not used, that would be amazing.
Yeah, I clearly remember in 2012, I was also doing a kind of analytics startups, and we had a hard time to figure out, all the Hadoop and securing the spot instances from AWS. Yeah. So let me just proceed to the next question. So you guys founded your company in 2012 in the small apartment in El Camino San Mateo in your apartment.
Yes.
And you launched your first product around in 2014. So you prepared 2 years. So could you please tell us what happened during those 2 years?
I mean, these 2 years started with a lot of discussion between Benoit and I in his apartment. The first thing we bought, because we knew we had to build a new data warehouse for the cloud, but we didn't really know at the time how we would be doing that. So we spent a lot of time trying to distillate what building a system in the cloud meant, what the elasticity of the cloud meant for us. We spent maybe 6 months, up to 6 months, both of us, in that apartment. We bought a whiteboard, we bought a printer. Took us a little bit of time.
Yeah. So any interesting story during those 2 periods?
Yeah, the great thing is that Thierry was doing the cooking, because I'm very bad at cooking, and I was doing the dishes. And we were working off my living room, so my wife was not that happy to have a big whiteboard and computers. We had 2 laptops, so we bought 2 laptops. We had a small server that we were sharing, it was in the closet. And as Thierry was saying, the goal was to determine what is the architecture that could leverage the cloud. And interestingly, when we left Oracle, we had no idea. We knew that we wanted to build, a system fully in the cloud as a managed solution. So we wanted simplicity, and at the same time, we wanted to, unify, structured data and semi-structured data. So we knew what we wanted to build, but we didn't know how to do it. So it was a bit scary. We had to jump in the water, so to speak, and see if we could swim. And we knew that if we didn't have an amazing idea on how to do that, we would probably, stop, the startup before it started, because we thought that the only way we can compete against the Oracle and the Amazon and all the big, data vendors, the only way we could compete is if we were building a product that was highly differentiated from its architecture. So that was the challenge.
Do you remember the launch moment, exact launch moment of your product, 2014? It was a type of a grand launching at once, or it was a gradual launch?
No, it was, so first it was 2015, right?
In the GA for the product was 2015, and we remember very, very well the months that led to that GA, because at the time we had our new CEO, Bob Meglia, and Bob was actually driving the weekly cadence, the monthly cadence of these different milestones that we had to hit before GA. And so we had we named each of these milestones with runs, ski runs. So we had we had Rapids, we had Challenger, we had Iron Horse, which was
because we were skiing. Okay, Snowflake comes from skiing and our passion from skiing. So everything at Snowflake is named after snow and something. And there was a North Star Lake Tahoe, ski resort, and it had a run. So we were naming all these milestones as runs in that particular ski resort. So we remember that GA moment. We had already customers before in 2014. Big, few customers that's hardened the product, but we wanted our GA to be very solid, right? With security and really call it, product that anyone could use.
But the last runs to GA was called Village Run. And it was called Village Run because this is the last run you take before you go home. And that was the name of the last milestone. So we remember these moments very, very, very clearly.
And one more interesting thing is that, you guys never were the CEO of your own company.
Yes. We always wanted to build a product. We never wanted really to build a company. So it's a little bit inverse. A lot of founders want to build a business. And therefore they want to be the CEO. We wanted to build a product. And for that, we had to build a company. And that was, I always say, collateral damage. No choice. So we never wanted and desired to be the CEO. And we thought that our special power, if you want, were not about, driving the business. Our special power were to build software. So we wanted to stay focused on the software and not, the business side. So we knew from day one that we wanted to hire, the best CEO and that's very important in our philosophy. I always say, building a startup and a few things about that yourself. But building a startup is a little bit like having kids. Right, except there is a big difference when you have, kids, the two parents are going to be there forever and you have only two. While when you build a startup, you bring, new talents, new expertise. And they are, these people are becoming really true parents of the kids. So the number of parents you can think about it, expands. And the CEO, of course, is a huge responsibility, but, the sales and, marketing, we had to add so many talents to Snowflake, and the magic of really building a company, I think, is to add these talents and these people that you can trust. Like really you trust, your spouse, and that's that relationship that you have with other employees and colleagues of Snowflake is critical. So to me, when people say, "Wow, you must be proud," I always think, no. Snowflake was not only us. Yes, we maybe started it, but Snowflake is so many more than just, the two of us. And that's very important.
I remember that, in the interview with the EO, you referred to some, the European and American analogy. So could you please tell a little bit about it to the audiences?
Yeah, I think you are referring to yes, the trust. So in the US, in Europe, so it was an employee. We hired an employee from Europe, and he was asking a lot of questions. He was very suspicious about how much, stock option he will get and what will be salary and how it was working. So he was asking a lot of questions. And at some point he said, Benoit, I'm asking all these questions because I'm from Europe. And in Europe, when you interact with someone, you always start at zero, right? Zero confidence. And then, as you know that person, you build up, you add, confidence, and then maybe you get to 100%, right? For your best friend. And so in the US, it is really the reverse. You always start at 100%. You don't know someone and you start to interact. You assume the best, you assume the best intents. And then potentially, you downgrade from there. But it was an interesting philosophy, and I to me, I very much like the US, model is like when you don't know someone, you assume, you assume positive, you assume, you give your trust, you might remove it at some point, you know, and that would be bad, but you entrust someone, you know, and that's what we did with Snowflake as we expanded the rank of employees working is really.
Okay, so let's shift the gear to the next one, data cloud. So I'll ask you a question to Benoit. So it's a question about the unique architecture of a Snowflake. The concept of a cloud, you know, the elasticity and the flexibility, simplicity is all common and it's quite natural in these days, but it was not back then, 12 to 13 years ago. So what was the kind of an aha moment of your architectural decision?
Yeah, so the aha moment was, working with Thierry in that apartment and realizing that in the cloud, fast is free. And we call it fast, going 2 times faster cost exactly the same amount of money as not going 2 times faster. So fast is really free. The way it works, right, in the cloud, if you have a problem and you know how to parallelize, so you have to see that these are analytical systems that can put, more compute resources to go faster, right, and to parallelize, processing of data. Let's say you have one compute resource. If you take 100 compute resources, 100 servers, in parallel, processing, data, you can go 100 times faster. But the price, because you go faster, you use these 100 compute resources 100 times less than if you had only one. So because you use these 100 compute resources 100 times less, even though they cost 100 times more because you have 100 of them, at the end it evens out and it's the same price. So when you look at compute in the cloud, you can dramatically accelerate, processing of data, go way faster than, you would go on premise. And at the same time, you don't pay more. And that's the compute model of Snowflake. We charge, by the compute you use, but also by the time you use this compute, such that, in Snowflake, we wanted, computing to go faster, for the same price. It really only is function of the processing you want to do, not how much, resources you use to do that processing. And that's the aha moments when we say, oh my God, in any system, traditional database system, when you grow that system, you have to pay much more, right? Not in Snowflake. And that was when we realized that with Thierry, of course, data systems are not architected to leverage that compute on demand. They cannot, in Snowflake today, it takes literally less than 1 second to allocate, 100, servers, and you can allocate as many pools of independent, servers and use them for whatever time. And, when you are done, you shut it down. So you can have all these compute resources all working on the same data, updating the same data. When, these different workloads are done, you just shut it down. And that's really the magic of the cloud and the elasticity. That was kind of the aha moment. The other aspect is you mentioned cloud, right? Snowflake is now a cloud. It's a true cloud in the sense that's not only we want to do processing of data, but we have added AI. So you have these different services like the cloud, which are based on this elasticity and this serverless. So you pay only for the compute that you use and for the time you use these compute resources. But also you can run applications, and that's very important for builders and so it started with the data layer, I guess, but it expanded to be a full-fledged cloud.
Let me ask you a question to Thierry this time. So I'm actually I was hearing a lot about the Snowflake because as I had a friend in the Iconic Capital, so he always notified what's going on in Snowflake, and I'm kind of feeling that at the beginning Snowflake was a kind of the cloud-based Hadoop plus an SQL server. But, suddenly it transitioned to some data cloud and data more than that. And then now you guys are transitioning to the, something combined with AI. So, could you please explain your transitional moment?
I mean, it's not so much of a transition than it is an expansion. Was Snowflake at the very beginning. We had to build a data platform in the cloud. We started with analytics because we are a little bit lazy and it's probably one of the easier problems to solve. When you have plentiful of resources, when you have the elasticity of a cloud and the resources of a cloud. But our ambition was, even at the beginning, our ambition was much more than that. And so over time, we introduce collaboration because the architecture of Snowflake allows for collaboration between inside a company but outside of a company, a little bit like Google Doc, where you can exchange not document, not a Google Doc document or a spreadsheet, but you can exchange between companies, share petabyte of data. No, and it was a little bit magical, and it is magical today to see how companies are creating that network of data, which is the data mesh in a sense, that mesh all this enterprise, and they exchange data, they create value. It's not so much that we had to switch and create new things each time. The platform expanded by its own nature. And, it's a little bit like a fish out of water that lands into a new place and grows legs and grows, start to walk on Earth. So Snowflake evolved over time, bringing strength from its DNA.
We build our, we call it the AI data cloud, and we built it, bottom up. And the first, key capability of the cloud was data, right? Data was so critical for us, and all type of data at any, scale. So it started with this data, art, if you think about it. Then we added, AI, and AI is super critical because, maybe we'll talk some more about it, but AI, needs data, but data needs AI, so somewhere the relationship between the two capabilities is very symbiotic. If you think about the cloud, is an operating system and is a modern operating system for applications to execute in. So first, when I say Snowflake is a cloud, oftentimes people say, but you're not a cloud like Amazon or Azure, right? You don't have data centers. Yes, we don't have data center. We decided from day one that we'll not build infrastructure. This is a little bit boring and too difficult to do. So we are the cuckoo cloud in the sense that we are creating this cloud diagnostic layer, and we ported, Snowflake on all the top of cloud providers, Microsoft, Azure, AWS with Amazon AWS, and of course Google GCP. And this abstraction that we created on top of each of these cloud provider allows, our application not to have any dependency with a particular cloud, and actually data can flow from different cloud region, and you can connect, as Thierry was saying, data set and your large organization can use, many clouds, many different cloud region and cloud provider in a unified way, right? We are a little bit the Linux of the cloud operating system. So you don't need to worry too much about which hardware you use, right? You are using Linux at the end.
So just for the audience's understanding, so could you please just get us some example of a petabyte of data? How big is it?
It will not fit in that room, I think. A petabyte is 1 trillion bytes. It's a lot of data. At the same time, you have to see that Snowflake highly compresses, data sets. So when we say you have 1 petabyte of data in a table, let's say in Snowflake, in reality, you have many more than 1 petabyte. Generally, depending on if it is semi-structured or structured data, semi-structured data compresses a lot more. So generally, uncompressed will be at least 10x or 20x, that volume. So you'll be really 20 petabytes of raw data that will compress down to 1 petabyte.
I mean, it's important. The world of data is exploding today. And there is a lot more data in front of us than there is behind us. And so you really want to have a platform that can scale and take advantage of that data going forward. Each and every of our customer can have multiple petabytes of data, and Snowflake itself is on multiple exabytes of data.
Yeah, I think our biggest customer has more something like 50 petabytes or 100 petabytes, just one customer. So if you take the sum of all our customers is a lot.
So, okay. So since most of the audiences are very interested in the AI thing, so let's shift the gear to the AI. I think that you guys are already working with a lot of famous guys in the Silicon Valley, Anthropic, OpenAI, and Google. You're all working together with the great companies. That Dario Amodei said maybe 2 weeks ago, maybe we're gonna reach some type of AGI situation until 2027. It says, what is your general take on the recent advancement, rapid development of AI models?
Before we go to LLM, and why AI and LLMs in particular are critical for data platform. Why is it used? Why is it even relevant, right? When you use ChatGPT and you use a data system, you don't see how they relate, right? So let's start just with that. So when we started Snowflake, I explained how our vision was to consolidate structured data and semi-structured data, right? But I didn't say anything about unstructured data. Unstructured data is any type of documents and I call it human-generated data, right? Human-generated data was a different type of data that you would never put in this data platform because, of course, you cannot process. You could store the data, right? Anyone can store files. That was not the problem. But you cannot, do processing on that data, do analytics, for example, on that data. Now with AI, you can do that, right? You can take a document, an image, a multimodal, document, and you can extract, information of it. You can structure that, generally generate, semi-structure from extracting, the information. You can, index, these documents and, search them in natural language, for example. So all of a sudden, data platform were relevant for unstructured data. So that's the huge revolution. For the first time in history, right, unstructured data became part of the data, data sets of any large organization. Now it's game. And people don't really know how to use this data, how they can leverage this data that has a lot of super useful information. A little bit like at the time when we started Snowflake, a lot of companies said, okay, semi-structured data, right, machine-generated data, what am I going to do with my logs, how to create logs, and this is complicated. So a lot of companies took a long time to use, to leverage this data. Now, every company leverage, machine-generated data. And I strongly believe that unstructured data in 1 year or now, actually, every company will, use, unstructured data and as part of their, data platform. So that's why it's so, critical for Snowflake. Now, if one aspect which is also super important for Snowflake is governance, right? Companies, large organizations, they don't want to send their data to anyone, to do any processing. They want processing to come to the data. And level 0 of the processing is LLMs, right? So that's why it's so critical for Snowflake to run inside the Snowflake security perimeter. So inside our cloud, right, natively run all these LLMs. So we are the only cloud. We have just announced, this partnership with OpenAI. We are the only cloud that can run OpenAI, Anthropic, even DeepSeek, Llama, Mistral, and all these great LLMs, run them, inside our data cloud, such that, our customers who want to use one of these, large language model, they don't need to send their data to an LLM service provider. The LLM is coming to them. But of course, it doesn't stop there. It's just, LLM is a core building block. As you said in your presentation, is you need to build, agents, or you need to build workflow with this LLM. You need to use them, and you need to, at the end, build applications, right? This is why it's so important for Snowflake also to run full-fledged application in our cloud, which can leverage, this level 0 of LLMs and build amazing applications that can, work on the data that our customers have, whether it's unstructured data or even structured data. So that's the philosophy, if you want, of our cloud.
Yeah, I totally agree with you. So actually, my company is also in that. I do have a similar experience because we are 300,000 numbers of a small beauty brand. Then we sold 4 million products, but all the database, the sales database was unstructured. So we then transformed it to the organized form. Now we can just ask LLM to make a query that really complicated, sophisticated query, so that the marketer directly talk to the data. That was the expression you used quite many times, talking to your data, right?
Yes, how to interact directly with data. And as I said, we want to this conversion, right? You talk to your data, and it is not that you don't talk only to unstructured data. You might talk also to your structured data. When you talk to your structured data, of course, you are going to use the LLM to generate, code, SQL, for example, to extract, the data which is relevant, to this interaction. When it's unstructured data, you might use, vector search, and it's a little bit different. And the agents, will direct to the appropriate, source of data. So creating this experience, and it's very important also to understand that you might extract, data from unstructured documents and then join it with structured data, right? Structured data know your customers, and so being able to do that in one platform is critical. It's very important to pick, back to my cloud, we are building a cloud. If you are starting a startup and you have to decide which cloud am I going to use, you want really these capabilities to be tightly integrated, right? The decision of what is your data platform, what is your data cloud, is a very important decision, because you need all these capabilities, very well integrated, because you don't want to spend all your time developing, type of technology.
So actually, I have one more question about that. Actually, even though we are just talking about how great LLM is, but I think that the actual application on huge amount of data and talking to the petabytes of the data, I think that it's not there yet, I think. So do you have any great example to show that how ready we are for paradigm of data?
There is a lot of these applications, but one thing which is important, I'll go to an example. As you said, we are not there yet, and you need to ground this LLM interaction with actually real system and predictable system and deterministic system in order to interact with these things, because both the input and the output of the system needs to be very well structured in order to get anything out of these systems. An example of a company which is not petabyte or terabyte of data, but which is quite interesting, is a small startup which is called Maxa.ai, it's an ERP system. And they are, large company have multiple ERPs. This company is aggregating all this ERP data from multiple of this ERP into a single ERP model. And they are building business functions. They have LLM that are building actually business application on top of this unified semantic model of this ERP data. So I don't know how large is their data, but
and one thing which is important to understand, this, and we have many, applications that are built in the Snowflake cloud, and the reason why Maxa, for example, has grown so quickly is because they are running inside. So the model of Snowflake is a little bit of an iPhone model, in the sense that as an application provider like Maxa, you can put your application on the marketplace, what we call it the Snowflake marketplace. You think of it as the App Store. So you can source your application in the Snowflake App Store, and our customers can take your application and install them in their accounts. Okay, so everything that this application has, and this application might even include some data from the provider, right? All these things are now installed and running in the security perimeter of the customer who is installing this application, right? A little bit like your iPhone. When you install an app on your iPhone, it can access, local, for example, your calendar or your contacts, but it's protected by the platform, right? So it's exactly the same model with native apps like Maxa. So Maxa was able to touch, all our large, customers, because our customers, they know that when they install, even though Maxa was a small startup, not very well known, they know that when they run, this application in their account, it has all the security guarantees, right? The application cannot exfiltrate data, for example. It cannot, and it can access local data that the customer has. So the ERP data that Thierry was mentioning is customer data, right? They don't want that data to leave. It's the most important, financial data of a company. No company wants to share that data with anyone. So having the expertise, the application going to the data is such an important, aspect. And that's what we enable with this, iPhone, application model.
So since you covered in most of the question we prepared for AI, so let me just get back to the general question of AI. So I asked you that, what do you think about, when do you think that we can achieve into AGI or things like that? Because I think that you guys have a lot of information.
It will not come fast enough for me.
Yeah, I don't know about AGI. It's super interesting, depending on who you talk, and we, of course, have a lot of interaction with. We have also our, at Snowflake, we build also our LLMs. And we are very, very into that technology too. And we have, top class, researcher actually on that subject. So they have a lot of insights. It's kind of interesting because even, people in that field don't really understand how it works. It's a lot of trial and error and the way they trained, this model, and we train our own LLMs, which was named Arctic. And it was fascinating to see, how they work and how they think about it. I think people who are in the field really think that it can be achieved, right? It's just, compute power, and at the end, you can build a neural network which is, maybe bigger than the human brain and or as big as the human brain.
But you will need multiple nuclear plants in order to power it, because the human brain is so, power efficient. But
then you have the cloning. So, the cloning is worth, it's a little bit science fiction now. I don't think we should be scared about it, because oftentimes AGI is used a little bit as a way to scare people. Like, okay, if machines are becoming as smart as human beings, what would be the world? And it's true that it has a lot of, open, questions. So I would not think too much about that. When you know how LLMs work, they are just, it's a prediction algorithm, right? They, based on their training and what they saw, they just predict, the next word. So it's not, it's not intelligence like human intelligence, I would say. But yeah.
In the past there was a Turing test. I think all the LLM today are passing the Turing test. I think we need a Roomba test, where you look at your Roomba, and if your Roomba eats your stocks, we have not achieved AGI yet. So that's the test you want to The physical world is actually a lot more complicated than the virtual world.
Which is true. I mean, when you see, even if you had a brain, as smart as a human brain, if it cannot, act on the physical world, is not yet, what makes us unique is our ability also to have physical interaction. So I think it will take some time. There's a lot of robotic, associated to it. So this is going to be a fascinating feat.
The Roomba test. I will be worried.
Siri had so many socks eaten by the Roomba.
Yeah, since we are running out of time right now, so let me just back to the last question, because there are so many talented tech entrepreneurs and engineers in the audiences. So could you please give some advice for the future tech entrepreneur, and they want to follow your trail?
We always say we never have advice. We don't like advice. Don't take any advice. Follow your intuition and what you think is right. Now, saying that, My advice will be to trust others. And, you know, as I said, you know, when you want to scale your company, if you are building a company, you know, having that and, you know, trusting the value of people, right at the end is not only talents that you bring, but it's people that you have to trust, right? As I said, you are bringing a new parents. And this is more than just, you know, competency. It's also, you know, values, you know, sharing the same values. And it could be, you know, values, company values, but it could be also product values, right? Snowflake, you know, simplicity, you know, making everything frictionless is such an important value of our products. That's, you know, when we hire engineers, you know, this is an important value that we have to share and that we look at, right? When we interview people. So it's important to think about your values. What are your product values or your company values? You know, what are your human values? Because at the end, we work all together and a functioning team oftentimes, you know, share the same, you know, passion, values, and so that's very important. That's a lesson we learn. And every time we compromise on that, we always regretted it when we say, oh, it doesn't have the same value and product value, but it's such a great competency that we should hire that person. We always regretted it. So don't hire someone just because of competency. Think about values. That would be one advice I would have. Then, you know, never hesitate to be ambitious. Never hesitate to be against, you know, everyone else. You know, if you have strong opinions, you know, go with your opinions. You know, when we started Snowflake, everyone told us it's never going to work because the system that will work is Hadoop, right? Hadoop is going, so either you are building a system on top of Hadoop or you are going to fail, right? Because Hadoop is such an amazing system. And we said, no, we believe Hadoop is really a bad system, actually. And, you know, Hadoop now is dead. No one is using Hadoop. There are still people using Hadoop, but it's not, you know, everyone knows that it was not a great system. So don't hesitate to voice, you know, what you strongly believe in. You know, belief is important, and staying true to your belief is very important. Don't, you know, go left, right, and you have to have a North Star, and it's very important, I think. You know, we talked about it, simplicity. You believe in simplicity. Don't compromise on that.
여러분요, 이 시점에서 박수. Any additional advice from your side?
I don't know, like Benoit says, we never give advice, but when I think back of 2012, the revolution was in the air. You know, everybody was talking about big data, about, you know, and I feel like today, last 2 years, you feel that the revolution is in the air again. There is a revolution, the AI revolution, there is a wind of change. Yeah. Which is, and everybody feels it. Nobody knows where the boat is going to go, but you know, there is revolution in the air. You want to be curious about that revolution. You want to be, you know, optimistic about that revolution. You want to be ignorant about that revolution a little bit to rediscover things that you are doing. So I think this curiosity and this ability to feel the wind is super important.
Thank you. 여러분 다시 한번 박수.
Thank you.